Welcome back to this video tutorial. We can discuss about the maximum mode configuration of 8086 in this video. Here it is the block diagram of maximum mode configuration, which include components like clock generator, 8086 CPU, address latches and data buffer. This data buffer is exactly equal to the transceiver unit present in minimum mode configuration. And here we have one more additional component, that is the 8288 bus controller circuit. Okay, this clock generator circuit provide input to this 8086 CPU. The inputs are reset, clock and ready signal, and also provide the clock signal to this 8288 bus controller circuit. Okay, and this bus controller circuit take inputs from this 8086 or the status output information available through this pin S0, S1 and S2 is taken as an input to this 8288 bus controller circuitry, and also it needs certain other inputs like AEN, IOB and CEN. Okay, and this 8288 generates certain control signals like IORC, IOWTC, MWTC, MRDC, etc. These control signals are generated for IO activities and memory access activities, and these signals are generated by decoding the value available through this S0, S1 and S2 status pins. Okay, and also this 8288 bus controller unit generate the ALE signal or the address latch enable signals in order for activate these address latches. These latches are used for holding the address information in order to make the address data multiplexed bus free, so that after shifting this address information into these latches we can use the bus in order for transferring data. So this ALE input to this latch is provided by this 8288 bus controller circuit. Similarly, it provides the DEN input and DT or R bar input, which decide the direction of data transfer, and these signals are also provided by this bus controller circuit to this data buffer or to this transceiver unit. Okay, so these are the input taken by this data buffer and is provided by this 8288 bus controller circuit. DEN bar indicate a valid data is available in the multiplexed address data bus now, and this DT or R bar signal actually indicate the direction of data transfer. DT equal to 1 means we want to transfer data from the processor side to the external, and if R bar equal to 1 or this DT or R bar equal to 0 means R bar equal to 1. This indicate the processor want to receive some valid data from external through this multiplexed address data bus now. Okay, so these are the input given to this data buffer and is provided by this 8288 bus controller circuit. Okay, so what is the significance of all these three input here, AEN, IOB and CEN? Now we can consider these input. Okay, AEN, IOB and CEN are the input signals of 8288 and is available only in the multiprocessor or maximum mode configuration. Okay, in minimum mode configuration all these pins are in a disabled mode. AEN or address enable causes the 8288 to enable the memory control signals. Okay, these AEN activate the memory control signals. Then the IOB, IO bus mode decide whether to perform a IO bus mode operation or system bus mode operation. The value on IOB decide whether or whenever we want to perform an IO bus operation or a system bus operation. The third input, the CEN, control enable input, enables the command output pins on 8288. It enables various command output of 8288. Okay, so all these are the functionalities of these 3 input AEN, IOB and CEN, these are not available in minimum mode configuration. Next, we can consider the usage of this output control signal generated by this 8 to 88. MRDC indicate a memory read command. It instructs the memory to put the content of the addressed location onto the data bus. Just to indicate a memory read operation by this MRDC. MWTC indicate or is a command for performing a memory write operation. IORC is a command for performing IO read operation, and IOWC actually a command for performing output write operation. We have one more control signal here which is not present in this diagram, that is the MCE or PDEN signal or command. Okay, this bus controller also it also generate one more command or control signal, that is the MCE or PDN, master cascade enable or peripheral data enable signal. It selects the cascade operation for the interrupt controller. Okay, it starts the cascading operation of 8 to 59 is an interrupt controller. It starts the cascading operation of this interrupt controller if the IOB signal is equal to 0. Okay, and enables the IO bus transceiver operation if IOB is tied high. Okay, so if the value of the IOB signal is low, then this particular command indicate a cascading operation of an interrupt controller, and this IOB signal is equal to 0, then this particular command start an IO bus transceiver operation. Okay, so all these are the control signals, and we have one more control signal which is provided by this 8 to 88 bus controller unit, that is the AIOWC or AMWC signal. Advanced IO write command or advanced memory write command. These signals are exactly similar to this IOWC and MWTC. IO write command or memory write command. But there is a difference, that is they are activated 1 clock pulse earlier. Okay, so these are advanced write command for IO operation and advanced write command for memory access operation, and the difference of these from IOWC and MWTC is that they are activated 1 clock pulse earlier, so that the slower external devices can start the requested write operation in a earlier time. So that is the significance of using this advanced write command. Okay, so all these are about the maximum mode configuration, and the main difference of this configuration with respect to the minimum mode operation is that here we have the one more bus controller circuit, 8288 bus controller circuit. This controller circuit actually generate various control signals in order to control the IO activities, memory activities, and also generate certain control signals in order to control this latches like ALE control signal, and also generate this DE and DT or R bar signal in order to control this data buffer or this transceiver unit. Okay, and the buses from these latches and the buffer is connected with peripheral devices like memory and peripheral IO devices. Okay, these external buses used for connecting this maximum mode configuration with external peripheral unit, so that we can transfer data to and from this external peripheral unit. Okay, so all these are about the maximum mode configuration. Thank you.